Welcome to an in-depth exploration of the DevOps lifecycle, a journey that transforms raw code into robust, deployed applications, seamlessly and efficiently. In today's fast-paced digital world, delivering high-quality software quickly isn't just an advantage, it's a necessity. Traditional development and operations teams often worked in silos, leading to friction, delays, and complex deployments. DevOps emerged as the transformative philosophy to bridge this gap, fostering collaboration, automation, and continuous improvement across the entire software development lifecycle. It's about breaking down barriers, automating tedious processes, and accelerating feedback loops, ensuring that what you code today can be live in the cloud tomorrow, with confidence. Join us as we demystify each critical phase, from the initial spark of an idea to the continuous monitoring of your application in production. We'll walk through the practical steps, backed by a real-world project, showing how every component contributes to a faster, more reliable software delivery pipeline. Get ready to go from understanding the theory to seeing the complete journey, from code to cloud. Our journey begins long before any code is written, in the crucial phase of planning and collaboration. This is where ideas take shape, requirements are defined, and the strategic groundwork for the entire project is laid. Think of it as charting the course for a grand expedition. Teams define user stories, outline technical specifications, and set clear, measurable goals. This isn't just about what to build, but how to build it collaboratively. Tools like project management software, communication platforms, and most importantly, version control systems like Git, become indispensable. Our example project, DevOps Cloud App, starts with a clear README.md, a vital piece of planning documentation that outlines the project's scope, purpose, and even the very phases we're discussing today. Git acts as the backbone, enabling multiple team members to contribute to documentation and code, ensuring everyone is working from the same, up-to-date source of truth. It's about aligning visions and ensuring every stakeholder, from product owner to developer, is on the same page before the first line of code is even considered. Once the planning is solid, we move into the heart of software creation, coding and version control. This is where developers translate requirements into functional code. Our example application, a simple Flask-based web service, resides in app/main.py. This file contains the logic for handling API requests, adding items, and checking health. Alongside it, requirements.txt lists all the necessary Python libraries our application depends on, ensuring a consistent environment for development. Every change, every new feature, every bug fix, is committed to our Git repository. This isn't just about saving files, it's about creating a historical record, enabling rollbacks, facilitating code reviews, and allowing multiple developers to work on different parts of the codebase simultaneously without conflicts. Small, frequent commits are a hallmark of DevOps, as they make it easier to pinpoint issues, merge changes, and maintain a steady flow of development. It's the continuous craftsmanship that forms the core of our software product. After coding, the next vital step is building and packaging. In the DevOps world, we don't just compile code, we create self-contained, portable artifacts that can run consistently across any environment. This is where Docker comes into play, a fundamental technology for modern application delivery. Our Docker file provides a blueprint, a set of instructions to create a Docker image of our DevOps Cloud App. It specifies the base operating system, installs Python and our application dependencies from requirements.txt, copies our main.py code, and defines how the application should start. This image encapsulates our application and all its runtime dependencies into a single, immutable unit. This solves the infamous "it works on my machine" problem, ensuring that the application behaves identically whether it's running on a developer's laptop, a testing server, or a production cloud environment. This standardization is crucial for speeding up deployments and reducing environment-related issues. With our application built, the next crucial phase is testing. In DevOps, testing isn't an afterthought, it's an integrated, continuous activity that ensures quality at every stage. We focus heavily on automated tests that can be run quickly and repeatedly. Our app/app_tests.py file contains unit tests for our Flask application, verifying that individual components of the code function as expected. These tests automatically check our API endpoints, ensuring items can be added and retrieved correctly, and that our health check is responsive. Automated testing provides immediate feedback to developers, catching bugs early when they are cheapest and easiest to fix. It builds confidence in the code base, allowing developers to make changes and add new features without fear of breaking existing functionality. This continuous validation is a cornerstone of rapid, reliable software delivery, preventing defects from reaching later stages of the pipeline or, worse, production. Now, let's talk about the automation engine that ties everything together, continuous integration, or CI. CI is the practice where developers frequently merge their code changes into a central repository, and after each merge, an automated build and test process is triggered. The goal is to detect integration errors as early as possible. Our project leverages GitHub Actions, orchestrated by the .github/workflows/cicd.yml file, to implement our CI pipeline. Whenever code is pushed to our repository, this workflow springs into action. It automatically fetches the latest code, installs all dependencies, and crucially, runs all our unit tests defined in app/app_tests.py. If any test fails, the build is immediately flagged, providing rapid feedback to the developer. This proactive approach prevents broken code from progressing further down the pipeline, saving significant time and effort in debugging later on. It's the heartbeat of our development cycle. Delving deeper into continuous integration, the cicd.yml workflow then proceeds to build the Docker image after all tests pass. This is where our Docker file is utilized to create the portable application container. By integrating the image build into the CI pipeline, we ensure that every successful code change results in a new, tested, and ready-to-deploy artifact. The image is tagged with the Git SHA, providing a unique and traceable version for every build. This automation means developers don't have to manually build images or run tests, the system handles it, providing consistent results every time. A successful CI run signals that our new code integrates perfectly, that all tests pass, and that we have a deployable artifact. This rapid, automated feedback loop empowers developers to iterate quickly and confidently, knowing their contributions are stable and compatible with the main code base. Following a successful CI run, we transition into continuous deployment, or CD. This phase automates the deployment of the validated application to various environments, potentially all the way to production. The first step in our CD pipeline, also defined within .github/workflows/cicd.yml, involves pushing the Docker image to a container registry. For instance, it could be Docker Hub or a private registry like Amazon ECR or Google Container Registry. This makes our immutable application image accessible for deployment. The image is typically tagged with both latest and the specific Git SHA, providing clear versioning. This automation ensures that once a build has passed all CI checks, it's immediately available for deployment, removing manual handoffs and potential errors. It's about getting verified software into a state where it can be released with minimal human intervention, dramatically reducing time to market. Now, for the actual deployment, the second part of continuous deployment. While our .github/workflows/cicd.yml handles the orchestration, the conceptual heavy lifting for deployment